Hi guys, so welcome back to another video. The topic for today is permutation. Okay, this is the second video as part of three videos that we have done for permutation and combination. The first one contains concept of basic counting. This one is the second one, which is permutation, and the one after this will contain combination. So if you haven't watched the previous video, I'll request that you watch that first and then do this. Alright, so without further ado, let's get into it. Right now, when we talk about, as we discussed in the previous video also, a lot of students get scared by the concept of permutation combination, and a reason for that is we think that this is like any other arithmetic topic where we need to know a formula, where we need to memorize formula, apply it. There are so many things. Okay, instead I'll tell you one thing: permutation combination is one of the easiest topics to do. Okay, the reason for that is half of the questions can be solved mentally. Alright, so for all the lazy students like me, right, half of it can be done mentally, and then we just write a little bit to get to the answer. Alright, so what we are going to focus in this video is we'll understand how to think, how to classify the question as a permutation question. Once we have classified, how to think about it, how to go about it, right? And let's try to make the questions or solving the questions and this concept very easy. Alright, so see, when we talk about permutation, alright, before we do, let's take some examples. Say I tell you what is 10 plus 2. Everybody will say 12. If I say 10 minus 2, you will say 8. 10 into 2, that's 20. 10 divided by 2, that's 5. So similarly, if I say 10p2, right, that is 90. Again, you don't need to know how to solve this, but the point that I am trying to make, okay, the point that I am trying to make is you are not scared of this plus sign. You know what the plus sign is, what it means, right? You know that if I tell you that there are 10 students in the class and if we add 2 more, there will be total 12 students. Similarly, you understand this minus sign or the multiplication sign or the division sign. Alright, so similarly, what I am urging you guys to do is understand the permutation sign. Okay, think of it like an operation. The way you have addition, subtraction, multiplication, division, similarly you have permutation and combination. Okay, you have a number before this, right? See, you have a number here before the plus sign, you have a number here after the plus sign. Similarly, we have a number here before the permutation sign, we have a number here after the permutation sign, right? The 10s and 2s are same everywhere. The only thing we then have to understand is when to use plus, when to use minus, when to use multiplication, when to use division. Similarly, when to use permutation. So question comes, when do we use permutation, right? We use permutation to tell us how many arrangements are possible. Okay, permutation will not arrange things for you. See, for example, if there are 10 students, 2 more join. The plus sign tells you that total there are 12 students. It doesn't tell you which 12 students are there, right? Similarly, permutation, okay, will tell you how many arrangements are possible. It won't tell you what the arrangement is going to be. Okay, it's only going to tell you the net result, that okay, these are the different ways. Alright, now the calculation part of it, we'll look at it further down the line. Okay, remember, permutation P or combination C, treat them or understand them as simple operations. The way you have plus minus, similarly you have P and C. The way you have a number before the plus and before minus, similarly you have number before P and after P. We need to understand the significance of this 10 and 2. Okay, once you understand that, solving will become easier. Moving on. Now, see, coming to permutation, again, as we discussed in the previous video as well, right? It's important, as I said, that the mental part of it is the most important part, right? So it's important to understand how do we decide when to use permutation. Okay, because another problem in this topic is some of the questions can be done using permutation and the same question sometimes can be done using combination. So we as a student get confused. What do I use? Like, do I use permutation? Do I use combination? The answer is coming from this, answer is coming from that, and we get confused, right? So what we are going to do is we are going to clearly categorize the questions. Remember, you get the answers from either. But if I know that, okay, for me, for this particular question type, I'll use permutation, then that clarity is there. And with that clarity, I jump into solving questions and I will always feel confident. Okay. So question comes, how do I decide, okay, when to use permutation? So remember, the first thing you will do is you will read the question and you will ask yourself if repetition is allowed or not. Okay. If repetition is allowed or not. Okay. What does repetition mean? That the same value can come again and again or not. Okay. If it is allowed, right? If that is a yes, then we will use counting. Okay, then we will use the concept of counting. Okay, again, as I told you, counting we have covered in the previous video. Okay, so if you want to understand that, watch the video just before this one. If repetition is not allowed, okay, if repetition is not allowed, then we ask ourselves, okay, fine, does the order matter or not? Okay, then we ask ourselves, okay, fine, repetition is not allowed, the order in which things are happening, okay, does that order matter or not? Okay, if the answer to that is yes, the order matters, then we say this is an arrangement. Okay, then we say that, okay, the following question is an arrangement question. If I say that no, the order does not matter, so then we say that, okay, this is a selection question. Okay, now if it is an arrangement, as I discussed before, permutation, okay, permutation will help us decide or tell or find how many arrangements are possible. Okay, then permutation is going to help you decide how many arrangements are possible. Okay, if order does not matter, right, then it is selection. Combination, okay, combination will then help you decide how many selections are possible. Okay, combination we will study in the next part. All right, today the focus is only on permutation. Okay, so remember, how do we decide when to use permutation? Read the question, understand it completely, talk to yourself and think, okay, can the same value repeat again and again? If the answer to that is yes, then you will use counting. Okay, then you will use counting. If the answer to that is no, then you will say, okay, then I have to use either permutation or combination. Then ask yourself, does the order in which things happen, does that order matter? If the answer to that is yes, you will use permutation to solve. If the answer to that is no, you will use combination to solve. Okay. Alright, so let's look at an example. Okay, let's look at an example or three different questions that will help us decide when to use counting, permutation and combination and understand the difference between the three. Okay. So again, see, there are 5 students in a batch. Okay, there are 5 students in a batch. What do we want? We want to avoid a prize to the best performer in the quant and verbal test. So we are going to conduct 2 tests for those 5 students. One quant test, one verbal test. Okay. Now ask yourself, say you are one of those 5 students. Can you win both the prizes? Right? What answer do you think comes? The answer is yes. As a student, I can win the prize for quant also, and if I perform the best in verbal, then I can win a prize there as well. So this is what we call that the variable or the value is repeating. Okay, so this is where we say repetition is allowed. Since repetition is allowed, we will do counting. Okay, since repetition is allowed, we will do counting. Okay, how do we do that? Again, we have done it in the previous video. What do? We make 2 blanks. This is for quant test, this is for verbal test, and I want quant and verbal. Because there is an and, multiplication will come. Now how many options are there for me to give a prize for quant test? 5 options, because I can give the prize to any of these 5 students. Similarly for verbal, again same 5 students, so total 25. Okay, so total I have 25 options. All right. moving on to the next question. Okay, moving on to the next question. Now, again you have 5 students in a batch. Okay, same 5 students. But now we are only conducting one test, quants test. Okay, say we are conducting a permutation combination test. Okay, what are we going to do? We are going to give 2 awards. One, a gold prize to the winner, silver prize to the runner up. So the top 2 performers, okay, in that order will get a gold and silver prize. Now again think to yourself or talk to yourself. Can you as a student get both the prizes? Like, can I get gold and silver both? The answer is no. I can either get a gold or silver or neither. But as same person cannot get both the prizes, right? So this is where, since I cannot get both the prizes, this is where I say repetition is not allowed. Okay, repetition is not allowed because the same value cannot repeat again and again. Okay, all right, repetition is not allowed. So then what do we do? There are 5 students, right? Does the order matter? Think about it. Let's take an example. Now another question or query comes that how do I decide whether order matters or not? So the simplest way to do is assume an example. Okay, assume a live case. Say for example here the students are A, B, C, D and E. Okay, we have 5 students A, B, C, D and E. Okay, scenario number 1, A gets gold, B gets silver. Okay, A gets gold, B gets silver, C, D don't get anything. Now if I interchange, okay, think about, say you get gold, I get silver. Okay, now let's interchange. So it's the 2 of us only getting the prize, but now what will happen? I will get gold, you will get silver. Is it the same scenario? Obviously not, because the price will change, right? Your medal is changing, correct? So when I interchange these 2, okay, when I interchange their positions, is it the same scenario or new scenario? The answer is it's a new scenario, right? Because it is a new case or new scenario, what do we say? The order matters, because the order in which A and B occurred, it mattered, because the moment I changed that order, I got a new scenario or a new case, right? So this tells me that order matters, right? And since the order matters, we will use permutation. Okay, we will use permutation. How will we use that? So that will be 5p2. Again, we'll come in a bit, we'll come to this. How do we get 5p2? What is the answer and all, right? Which is 20, right? We get 5p2. All right. Moving on to the third question type. Again, there are 5 students. Okay, we are awarding 2 same chocolates to top 2 performers. Okay, now we say now the situation has changed. Instead of awarding a gold and a silver prize, what are we doing? We are awarding 2 prizes, but it's the same chocolate. Okay, again think, can you as a student get both the chocolates? Again the answer is no, because if you are the first one, you can't be the second one at the same time. So it tells us repetition not allowed, right? Now let's do the same scenario. Okay, say you are the first person, I am the second one, so both of us get the same chocolate. Okay, if we interchange our positions, say I am the first one, you are the second, has the situation changed? No, because we are still getting the same chocolate, right? Think about it. If I do AB or I do BA, right, it's still the same thing, right? It is still the same thing because you are getting the same chocolate. So since both the scenarios are same, right, since both the scenarios are same, what do we say? Order does not matter. Okay, whether you put A in the first position or second, it doesn't matter. Obviously first and second matter because it's chocolate versus non-chocolate, but for chocolate A, B, B, A are the same, right? So we say order does not matter. Order does not matter means we will use combination. So the answer will become 5C2. Okay, again, how the answer comes, how do we solve 5C2? We'll see combination in the next part of the video. Okay, but again, the point is, guys, try to understand. Okay, try to categorize the questions clearly in your mind. Okay, if you are able to do that, your life will become easy. You will know that, okay, I have to think in terms of permutation only, or I have to think in terms of combination only, or I have to do counting, right? Your life will become easier. You'll understand what operation to use. Remember, permutation, combination, treat them as operations, treat them as plus or minus. Don't treat them as any formula or anything. Okay, I hope you understand this. Alright, now that we understand the differentiation between the three, let's dive deep into the concept of permutation. Alright, so say I want to arrange, okay, R things, okay, I want to arrange R things out of N things. Okay, see, we have understood this by now, that permutation tells us how many arrangements are possible. It won't arrange the things for me. Instead, it will just tell me how many total arrangements are possible. Okay, total options that are there, right? So if I have n things, okay, so in my head, or if I am somebody who's trying to arrange stuff, I have a total choice of n options or n things, but out of those n, I only want to arrange R. Okay, if you look at a previous example, we had 5 students. Okay, there were 5 students, and I wanted to give a gold and a silver prize. So I wanted to give prizes only to 2. So even though I had a choice of 5 students, I wanted to give prize only to 2 students, right? So I have n options, but I want to use only R out of those. So then we do NPR, okay, which is n factorial by n minus R factorial. Okay, then we do NPR, that is n factorial by n minus R factorial. Okay, so if you look at the previous question where we had 5 students, but we wanted to give prize only to 2, the answer becomes 5 factorial by 5 minus 2 factorial, which is 5 factorial by 3 factorial. Right? Now I'm assuming all of us already know what factorial is. So 5 factorial is 5 into 4 into 3 into 2 into 1. 3 factorial is 3 into 2 into 1. Cancels out. 5 into 4, that's 20. Okay, that is 5 into 4, 20. Okay, so remember, how do we use basic permutation? What is the what do you say, significance of value before P and significance of value after P? Before P is the total options that I have. After P, how many out of those options I want to use. Now the R, the value of R can be equal to N as well. Okay, for example, say I want to make a 5-letter word using A, B, C, D, E. Okay, I want to make a 5-letter word using the letters A, B, C, D, E. So I have 5 options, and I want to make a 5-letter word means I want to use all 5 options. So the answer becomes 5p5, which is 5 factorial by 0 factorial. Okay, now remember, 0 factorial is 1, 1 factorial is also 1, 2 factorial is 2 into 1, which is 2, 3 factorial is 3 into 2 into 1, which is 6, and so on. Okay, with enough practice, I'll request that you guys learn factorials up to 10 at least. Okay, with enough practice, I think you should learn factorials up to 10. Okay, so this, if we continue, that's 5 factorial by 0 factorial, which is 5 factorial by 1, which is 120. Okay, again remember, the value before P is the number of options I have. The value after P is the number of options I am going to use. Alright, and we have NPR, which is n factorial by n minus R factorial. Okay, so every time you are solving a question, just think, how many options do I have? How many do I want to use? Right, and then you simply apply NPR. Okay, Remember, what is this telling me? This is telling me how many ways can the arrangement be done. It's not telling me what is the arrangement. It's just telling me in how many ways that arrangement can be done. Okay. Now, one thing with respect to your calculations, okay, remember n factorial. Okay, n factorial, right, can be written as n into n minus 1 into n minus 2 up till 1. Right? If I just take this n as it is, all of this combined is n minus 1 factorial. Okay, or n into, I can take n minus 1 also common. What is left? This is n minus 2 factorial. Okay, what the point I am trying to make is that here 5 factorial can be written as 5 into 4 into 3 factorial. Okay, because it's 5 into 4, this 3 to 1 is 3 factorial. Divided by 3 factorial, the factorial cancels out. 5 into 4, 20. Okay, so with this you will realize one thing: calculations are not that tough. Okay, calculation is not a problem in this topic. Okay, it's all about thinking and understanding whether I can apply the concept and get to this step. Okay, so if you understand the basic concept of permutation, right, then what happens? In question we get various types of constraints. Okay, we get various types of constraints. Constraints will be like, okay, constraints will be like, there are 5 friends, they want to go watch a movie. One particular person wants to sit in the middle only, or one person wants to sit particularly in the ends. Okay, or we have a 5-digit number and we want the number to be even number. Okay, so whatever the constraints are, okay, think when you're solving the question, think that if this happens to me in real life, what is it that I do first? Okay, for example, say there are 5 friends. Okay, they are going to watch a movie, so they will sit in 5 seats. Okay, say a particular friend A wants to sit in the corner seat. Okay, now say you are the person who's supposed to manage this. Okay, so what will you do first? You will ask A that, okay boss, you sit first, right? Okay, you are the like one who's throwing tantrums, or you have your own choices. You go, you sit first, right? So what will we do? I have, for A, how many options do I have? I have 2 corner seats. How many people that I want to use, right? I want to use 1 seat out of those 2 and assign that to A, right? So I have 2 options, but I want to use only 1, and this is for A. Now that my constraint is over, okay, now that my constraint is over, all the others, they are not fuzzy, they can sit anywhere. So I have 4 options and I want to seat all 4 of them, right? I have 4 options and I want to seat all 4 of them. So that simply becomes 4p4, right? And now you just solve it, right? So again, as I said, the point is, it's all mental. Okay, you can solve half of the question mentally, and then we are just putting these numbers, right, to calculate. Okay, so 2p1 comes for A, because what do? I try to get rid of the constraint first. Okay, what do? I try to get rid of the constraint first, and then I arrange the rest. Okay, so this becomes 2 into 24, that's 48. Okay, right? Similarly, there can be other constraints. The point I am trying to make here is that if you have a question with a constraint, okay, if you have a question with a constraint, no problem. Okay, always try and solve the constraint first. Okay, always try to solve the constraint first. Okay, and then you can arrange the rest. Okay, so always your thinking should be that, okay, let me solve the constraint first, let me get this out of the picture, and then you arrange the rest. Okay, if you do that, you'll find solving all these questions very easy. Okay. Alright. So let's look at this question then. Okay. What do we know? We have 5 digits 1, 3, 5, 7, 8. Okay. We want to make a 5-digit number out of these. Okay. So I have 5 digits and I want a 5-digit number. Okay. The first digit has to be odd and the last digit has to be even. Okay. Now before jumping in and trying to get the answer, right, think first. Okay, think. Why is permutation applicable here? Because step number 1, is repetition allowed? No. I can't use 1 again and again. Right? So repetition is not allowed. Does the order matter? Yes. Because if I have a number 13578, right, versus 31578, both are different numbers, right? See, if I have a number 13578 and another number 31578, what did I do? I changed the positions of these two, right? I changed the order. Are the two numbers same? No, these are two different numbers. So what will we say? The order matters. The order in which I write down these numbers, that order matters. So I know repetition is not allowed. Order matters. Hence, we are using permutation to solve this. Okay. Again, throughout these questions, this is what we are going to do. For every question, we'll try and understand why permutation is applicable. Okay. Now that I know this, I have constraints. I have to make a 5-digit number. The first digit has to be odd, right? The first digit has to be odd. I say no problem. Let me get rid of this constraint first. How many odd numbers do I have? I have 4 options. Okay, 1, 3, 5, 7. I have 4 options. How many do I want in the first place? Only 1. So I have 4 options and I am using 1. That is why 4p1. Constraint 1 over. Now the last digit has to be even. How many even numbers do I have? I have only 1 option. How many do I want to use? I want to use only 1 out of that. So that is 1p1. Now that my constraints are over, I solve the rest. So I have 3 numbers left because I would have used one of the 4 odd numbers and 1 even number. So I have 3 numbers left. I want to use how many of those 3? All the 3 to come here, right? So 3p3, 3 options, 3 I want to use, hence 3p3. If I solve that, 4p1 is 4, 3p3 is 3 factorial, 1p1 is 1 factorial. So that is 24 cases, right? That is 24 cases. Again, remember, calculation is not that difficult. It's all about the thinking, right? So when you read the question, don't just rush. Think, categorize it, structure it, so that you understand what is happening. Alright, if you understand this, let's move to a different type. Okay, a common question type that comes is when are things out of n come together. Okay, when they say are things out of n things come together. Remember, n things are the n options that I have, are the things that I want, right? And when they say are things out of n come together. Okay, let's understand this with an example and then we'll make a formula of our own, right? So say we have 6 girls, okay, and 3 boys. Okay, so we have a group, 6 girls, 3 boys. They are going to watch a movie. Alright, they are going to watch a movie. So they'll sit in 9 seats. Okay, they'll sit in 9 seats. Now the question is that all the boys will sit together. Okay, all the boys sit together. Okay, alright. So we'll say, okay, no problem. Now before we solve this, again, is it a permutation question? Yes, because same thing cannot repeat again and again. Plus, the order in which they sit, it matters. So we know it's a permutation question, right? Now, The question says that all the boys want to sit together. So I'll say no problem. You want to sit together? Fine. Let's do one thing. Let's combine them and count them as one entity. Okay. So what will I do? In my mind, I'll say, okay, fine. I'll just combine the three of you and look at the three of you as one quantity or one unit, so that wherever I place that unit, I know the three of you will go and sit there. Okay. So what do? We combine the three, okay, and consider them as one single unit. Okay. And the girls, they'll be 6 girls itself. Okay, because they are all individual, they are all separate, they don't have any problem, they can sit anywhere, right? So now I have 6 girls and 1 X. Okay, now I have 6 girls, which are 6 individual, okay, people, and this 1 X. The X is for all the 3 boys combined. Okay, so I have 6 and 1, 7, and I have to arrange all 7, because wherever this X goes, the 3 boys will go and sit there. Okay, so it's not as if that there are 7 people now. Okay, there are 7 units or 7 quantities that I want to arrange. Okay, wherever this X goes, the 3 boys will sit. Now you might think that, okay, what about the seats? The seats are still 9. So think of it like this: the 3 seats where the boys will sit together, I've combined it into one sofa, a 3-seater sofa. Okay, so now I have 6 single seats and 1 sofa. Wherever I place the sofa, the boys will sit there. So you can think of it like that also. If you don't want to mix boys, you can think in terms of seats also, that okay, instead of having 9 seats, okay, I have 6 individual seats and 1 3-seater sofa. So wherever I place that 3-seater sofa, the 3 boys will go and sit there. Okay, so now that I have 7 things, how many ways can I arrange them? 7p7, because I have 7 options and everybody has to sit. So I have to pick all 7 of them. So that becomes 7p7, right? This 7p7 is because of these. Now that I have decided, okay, girl will sit here, 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 and X will come here. Now what will happen? The 3 boys will go and sit on that sofa, the 3-seater sofa. So the boys can further arrange themselves, because they will see, okay, there are 3 boys, there is a 3-seater sofa, so 3 seats. I want 3 boys to sit in 3 positions, so that is 3p3. Okay, so what will happen? Initially, girls, and combine the boys into 7 units, arrange those 7 units. Now that is done, the girls have gone and sat. Wherever the 3 units are left, the boys are supposed to go there and sit. But there are 3 boys, 3 positions, they can also arrange themselves. Okay, so how many ways can they arrange? That's 3p3. So this becomes 3p3. So that's 7 factorial by 0 factorial, 3 factorial by 0 factorial. If you simply solve this, that is 5040 times 6, that's 30240, right? 30240 cases. Okay, I hope you understand the logic of this. Okay, I hope you understand the logic of this. Okay, so now let's convert the same thing into a formula. Okay, so you have total n things. Okay, out of this, R will come together. Okay, so then what will be the total number of ways? That is simply n minus R plus 1 factorial into R factorial. Okay, if you try and understand, if you try and see, in this example, I had 6 girls plus 3 boys, total 9 people. Okay, out of these 9, 3 boys wanted to come together. Okay, so if I apply that, I have 9 minus 3 plus 1 factorial times 3 factorial. That is 7 factorial times 3 factorial. Okay, n is the total. I remove the 3 boys, so that is I remove R, but then I have to combine them and count them as 1, hence the plus 1. And this R is the internal arrangement of the boys. Okay, so I hope you understand the formula. This is the logic If you understand this, you can simply apply it directly while solving the questions. Okay. So let's look at the question based on this previous concept. So see, we have 10 seats are there. Okay, 10 seats are there. Okay, and there are total 10 friends. Fine. Now among these 10 friends, there are 3 pairs of friends. Okay, among these 10 friends, there are 3 pairs of friends. Okay, and these pair, they insist on sitting together. We say fine, no problem. Okay, you are 3 pairs, you want to sit together, fine, no problem at all, sit. Okay, now the question is, how many ways can they be seated? So again, let's quickly look. Can the same person repeat again and again? No, repetition not allowed. Does the order matter? Yes, it definitely does matter. So we have to do permutation. Okay, now what is happening? I have 10 friends. Okay, within these 10 friends, there are 3 pairs. 3 pairs means 6 people, right? Say A1, A2, pair number 1, B1, B2, pair number 2, C1, C2, pair number 3. Apart from this 6, there are 4 more people. Okay, say D, E, F, and G. So these are my 10 people. Now, the pair, like these pairs, they want to sit together. But this does not mean that A1, A2 has to sit with B1, B2. A1, A2 will sit together. They can sit away from B1, B2 also. A1, A2 needs to sit together. B1, B2 needs to sit together. C1, C2 needs to sit together. Right? Okay, remember this. It does not mean that the 3 pairs means that the 6 people will sit together. Each individual pair will sit together. They can sit next to these or they can sit away from each other, anything. But the individual pair needs to sit together. Okay, so we say fine, no problem. Combine them into one, that's X. Combine them into one, that's Y. Combine them into one, that's Z. You still have D, E, F, G. So I have total 7 people or 7 units left. I want to arrange all of them, so that's 77. Now within this X, there are 2 people, so that's 2P2. Within this Y, again there are 2 people, so 2P2. Within this Z, again there are 2 people, so 2P2 again, right? The 7 comes because of 1, 2, 3, 4, 5, 6, 7. Okay, 2P2 comes because of the internal arrangement that is happening in X, Y and Z respectively. Alright, so total ways, that's 7 factorial, 2 factorial, 2 factorial, right? Remember the denominator is 0 factorial and 0 factorial is 1. Okay, so you write, you don't write, it's the same. 7 factorial guys is 5040 times 2 into 2 into 2, that's 8. That's 40320. Eventually 8 factorial. Okay, because 8 into 7 factorial is 8 factorial. So 40320. Okay. Now if you're wondering how do we apply the formula that we made, so same way. See, out of n, okay, n is 10, 3 pairs want to come together. Okay, so what will I write? 10 minus 2 plus 1 because of A1, A2, right? Then minus 2 plus 1 because of B1, B2 and minus 2 plus 1 because of C1, C2. That's n minus r plus 1 factorial. Because of A1, A2, minus 2 plus 1. Because of B1, B2, again minus 2 plus 1. Because of C1, C2, again minus 2 plus 1. Times r factorial. So because of A1, A2, 2 factorial. Because of B1, B2, 2 factorial. Because of C1, C2, again 2 factorial. So that simply becomes 7 factorial times 2 factorial, 2 factorial, 2 factorial, which is 40320 again. Okay, so this is how you can directly apply the formula to solve or understand the logic to solve. Alright, so if you understand the previous type, let's move to the next one. Right, this is again very simple. It says when all of our things out of n do not come together. Okay, alright, what does this mean? So let's take the same example. We have 6 girls. Alright, we have 6 girls. We have 3 boys. Okay, in the previous set we did all the boys should sit together. Now we want all the boys can't sit together. Okay, so what does that tell you? 2 boys sit together, I have no problem. All of them sit separately, I have no problem. But all 3 cannot sit together. Okay, remember this is super important. All, right? This is super important. All do not sit together. Okay, so when we say all of them cannot come together means some of them come, no problem, but all of them cannot. Okay, specifically in this example, 2 boys sit together, no problem, 3 can't. All right, so the logic to solve this is very simple. Okay, so say if you think about it, say let me ask you a question. Say there is a 80% chance that it is going to rain today. Okay, say there is a 80% chance that it will rain today. Okay, now if I ask, so what is the percentage chance that it will not rain today? So we say 20%, right? 20% comes to your mind. Okay, what did you do here? You did total is 100%, 80% is for raining, so the remaining 100 minus 80, 20% means it will not rain. So similarly, using that logic, they say all of them cannot come together. I say fine. What will I do? I will simply do total cases minus the cases when they come together. Okay, what will I do? I'll say fine, no problem. So what will I do? I'll do total cases minus the cases when they come together. Right? Now total cases, I have 9 people. They can sit anywhere they want. So that's 9p9. Okay, minus the cases when they come together. This we have done in the previous one. Okay, we'll combine all the girls into one, sorry, all the boys into one count. That's 7p7 times 3p3. Okay, so that's 7p7 minus 3p3 into 3p3, right? So if you want to understand this, or if you want to solve such question type, it's very simple. It is total cases, right? You simply do total cases, okay, minus the cases when all come together. Okay, so if you're looking for a formula, that is n factorial, which is for total cases, minus n minus r plus 1 factorial times r factorial. This is for cases when they come together, right? Okay, total minus cases when they come together. Continuing on the same. So see, remember the previous one was all of them can't come together. That means the 3 boys, 2 sit together, I have no problem. All 3 can't sit together. Okay, that was the question type. Now if you read this next one, it's an interesting question. It says when none or no 2, okay, when none or no 2 of r things out of n come together. This means now they are saying I don't want any of these to come together. Okay, if you look at our example again, we have 6 girls, 3 boys. Now we are saying even the 2 boys can't sit together. All the boys have to sit separately. Okay, remember, understanding the difference between the two is extremely important. Okay, understanding the difference between the two is extremely important. Okay, what are we saying here? We are saying none of the boys can sit together. So even 2 can't sit together. In the previous one, 2 sitting together, not a problem. All of them sitting together, problem. Okay, so if I have 6 girls, 3 boys, and the question is, okay, none of the boys sit together. Okay, I say fine, no problem. Let's again think of it logically. How will I solve this logically, or what will happen say if this is the real life? So what do? I say okay, boys have a problem now, boys can't sit together. I say fine, no problem, you come out. I have 6 girls now. what will I do? I'll ask the 6 girls to go and sit. Okay, so I have 6 spaces. Okay, in this 6 places the girls will sit. Okay, 6 girls, 6 positions, so 6p6 space. 6 girls will go and occupy 6 positions, so 6p6 space. Okay, now see, remember, I am supposed to ensure that the boys never sit together. Okay, so I'll say, okay, the girls have sat. Now look at the options that are available for boys. The boys can sit in any of these 7 positions, because in these 7 circles I can put one boy anywhere I want, and wherever I put that boy, I have ensured the boy is not coming next to another boy, right? So I have 7 options available. Okay, I have 7 options available. How many options am I going to use? Only 3, because there are only 3 boys. So I have 7 options available, but I am going to use only 3 for the boys. Okay, so answer becomes 6p6 times 7p3. Okay, now you might think, okay, let that sink in. Let try and understand this. Let that sink in. Now some of us might think that, but these are 13 seats, but we don't have 13 seats, right? We have only 9 seats, right? I understand that. So let's do an example, right? It's not that we have generated more seats. It's just that I have that many options available. I am using only 9 seats. Say for example, if you say that, okay, I am sending boy number 1 here, boy number 2 here, and boy number 3 here. Okay, so that does not mean that there is an empty seat here. I'll just remove those seats. Okay, what will happen? My arrangement will look like this: girl number 1, then boy number 1, girl number 2, boy number 2, girl number 3, girl number 4, girl number 5, girl number 6, and boy number 3. So they will sit like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. They will sit in 9 positions like this. Okay, these are imaginary positions that I have. These are not actual seats. I have not asked girls to keep a space of one seat. Okay, it's an imaginary option that I have. Okay, so ultimately we have 9 seats only. Okay, alright, if you understand this, let's formulate it then. So again, if I have n things, okay, none of r come together. Okay, so in this case, right, in this case we had 6 girls, 3 boys, so total 9 things or 9 people. The 3 boys cannot come together. So what did we do? We first arranged all the girls. So that is n minus r factorial. Okay, this is for the girls. Now next to the girls I have those imaginary positions. How many are these? N minus r plus 1. These are the imaginary positions that I have. From these, how many am I going to use? R, because that many boys are there, right? So this is the formula. Okay, if you try and solve it, that is 9 minus 3, which is 6 factorial, times 9 minus 3 plus 1 p3, which if you solve is 7p3. Alright, so if you read the question, I think this is what we have solved just now. See, we have 6 students, 3 teachers, so again 9 people in total, right? We want to ensure no 2 teachers sit together. Again, think about it. Is repetition allowed? Clearly not, right? Is repetition allowed? Clearly not, right? Does the order matter? Yes, it matters. Who sits where? The order matters. So we know it is permutation. Now, the important point is no 2 teachers sit together. Okay, no 2 teachers sit together. What does that tell you? That all of them have to sit separately. Okay, all of them have to sit separately. So this is my second method. It's not all the teachers can't sit together. It's a Second method, where even the two can't sit together. We have solved this just now. We'll ask the boys to sit first. So that's 6p6, right? This is where, or this is how the boys will sit. Now next to the boys, these are the 7 options, 7 imaginary options, where I will ask the 3 teachers to sit. So that is 6p6 into 7p3. That's my answer. Alright, so if you understand the previous concept, let's move to a different type. Okay, that is the concept of redundancy. Okay, now redundancy is slightly different from repetition allowed. Okay, redundancy is slightly different from repetition allowed. Okay, let's understand the difference between the two. So before we do that, let's take an example of what is redundancy. Say I tell you that I have a 5-letter word apple, and I have 5 letters apple. I want to make another 5-letter word out of it. Okay, how many words can I make? All right, so at the outset of it, I have 5 letters, right? I have 5 letters and I want to make a 5-letter word, so it should be 5p5, right? Where is the problem? 5 letters, 5 options, use all of them, 5p5. The problem comes if I interchange the two p's. Okay, the problem comes if I interchange the two p's. Am I getting a new word? The answer is no, right? Am I getting a new word? The answer is no. So the two p's are creating redundancy in two positions, right? Now, what is the difference between repetition allowed? Because you might think that, oh, this is repetition allowed then because p is being repeated. No, when we say repetition allowed, it means anything can come any number of times. You can't do that, oh, only p will come 2 times, rest all can't come. Repetition allowed means any of these letters can come any number of times. So I can have a 5-letter word called A. Okay, if I have repetition allowed, then I can have A coming 5 times. Okay, that is also a code. Think of it like, let's look at it a question. I tell you that I have 4 letters APLE. Okay, I want to make a lock code, right, for my briefcase or for as a password. Okay, I want to make a 5-letter password. Right, now in a password, I can use the same letter again and again. So one of the passwords can be A, right, 5 A's, right? That is where we say repetition allowed. Now in this question, what did I say? I said these are the 5 letters. I want to use all the 5 letters, okay, and make a 5-letter word. Okay, so what is happening? The two p's are repeating, right? So they are creating redundancy in two positions. All right, I hope you understand the difference between repetition allowed and redundancy. Okay, now if you do, solving redundancy is very simple. I will say I have 5 letters, right? If I were to solve it normally, what will I do? I'll say I have 5 letters, I want a 5-letter word, so 5p5. But the problem is the two p's are creating redundancy in two positions. Even if I interchange them, I am getting the same word. So in order to remove the redundancy, we divide by 2p2. Why 2p2? Because two p's are creating redundancy in two positions. Okay, say another example, right? Had we had say A, so now I have 7-letter word and I want to make a 7-letter word out of these letters. So that would have been 7p7, but two A's are creating redundancy in two positions and 3 P's are creating redundancy in 3 positions. Okay, we don't divide by 5p5. Why? Because if I interchange A and P, I get a different answer. A and P are not creating redundancy with each other. A is creating redundancy with A, that is why 2p2. P is creating redundancy with these 2 P's, that is why 3p3. Okay, so again, if you want to solve the questions in case of redundancy, what do we do? Simple. Solve normally by assuming everything different. Okay, so you solve the question normally, assume everything is different, they say vowel should come together, vowel should not come together, all the things that we have learned till now, right? All the letters should come together, or all the P's should come together, not come together, whatever they say, right? Begin with a vowel, end with a vowel, begin with a consonant, whatever constraints they put, solve the question normally. Once you have solved, then divide by redundant factorial. Okay, then you simply divide by redundant factorial. So what will I do? I will solve normally on the top and simply keep dividing the answer by whatever is redundant. Okay, I hope you understand this. Let's look at an example to solve. You've read the question, right? You will realize we have 5 identical copies of 4 different books. Okay, so say the 4 different books are A, B, C and D, and we have 5 redundant copies. So that means I have 5 A's, 5 B's, okay, 5 C's and 5 D's. Okay, these are the 20 books that I have. I want to arrange them on a shelf. Okay, how many ways is it possible? So if I have 20 books and I want to arrange all of them, right? Again, think there is redundancy because these 5 books all look alike. So even if I interchange them, I don't get a new case, right? So 20 books to be arranged in 20 places, that's 20p20, right? Divide by 5p5 for A, 5p5 for B, 5p5 for C, 5p5 for D. Okay, so that's 20 factorial by 5 factorial power 4. Okay, 20 factorial divided by 5 factorial power 4. Now guys, here itself let's see a different case. Okay, when I say none of the A books can come together. Okay, so it's the same question, but now we are saying we have to arrange 20 books in 20 places on the shelf, that's okay, but none of A books come together. Okay, none of the A books or no two A books, whatever you want to call it. So what will we do? We will solve normally by considering everything different. So A, what will I do? I'll arrange these 15 first, right? I'll arrange these 15 first. That's 15 factorial ways. Next to these 15, I have 16 options. In those 16 options, I have to put 5 books. So that's 16p5. Okay. In the end, again I divide by whatever is redundant. Okay. So the point I am trying to make is, doesn't matter what they ask in the question. Okay. You solve the question normally by considering everything to be different. Solve it. In the end, just divide by whatever is redundant factorial. Okay. Alright. Moving to the next type. This is the concept of circular permutation. Okay. Now circular permutation is, see, whatever questions we did till now, we were arranging items in a row or in a sequence, right? A linear sequence. But that's not necessary that people always sit in a straight line. They can sit in a circle as well. Right? So then what happens? Like if we ask the same people to sit in a circle, so what changes happen? Okay, or what is the difference? So again, let's take the same example. We have 6 girls, 3 boys. Okay, let's take scenario number 1 when they simply sit in a circle. Okay, no constraint, no nothing, just simply sit in a circle. Then we will look at all sitting in a circle but all boys together. Okay, all boys together. Okay. So now what happens? See, when you sit in a circle, these are 9 people had they sat in a row, okay, row versus circle, okay, scenario number 1. Had these 9 people sat in a row, what would have happened? I would have arranged them either left to right or right to left. Okay, I would have arranged them either left to right or right to left. Point being, I would have had a starting point, a fixed starting point and a fixed ending point, right? Right? I would have a fixed starting point and a fixed ending point. So I would know ki haan, okay, this is how I have to do. Okay, if I'm starting from left, I am ending at the right. If I'm starting at the right, I'm ending at left, right? I would have arranged them in 9p9 ways, because nine people or 9 things, and I want all 9, right? Now the problem is, if they are sitting in a circle, right, sitting in a row, these are the 9 positions. Either I start from here or start from there, right? I have a fixed starting point, fixed ending point. Now the problem is that if they are sitting in a circle, okay, if these people are sitting in a circle, 1, 2, 3, 4, 5, 6. So these are the 9 positions. Now the problem is, I don't know where to start my counting from. Okay, the problem is, do I start my counting from here, or do I start here, here? Where do I start my counting from, right? Because in a circle, I don't have a fixed starting point and an ending point. All right. So what happens? We have to sacrifice. Okay, we have to fix one variable in one position. Say for example, I'll pick one person out of these 9. Say I pick boy number 1, and I say boy number 1 will always sit here. Now my counting will start from him. Now it doesn't matter. Now you go clockwise or you go anti-clockwise. You know, if this is my starting point, if I go like this, the moment I reach boy number 1, I know circle is over, or this is my last point, right? So what has happened? One variable got fixed in one position. One variable, one position, already done. Okay, this person was fixed here. So now how many am I arranging? The remaining 8 I can arrange anywhere. Okay, remaining 8 I will arrange in any way I want, right? So the difference between a row and a circle is simply, you have to fix one person in one position. Okay, we try to fix one person in one position so that we know that there is a clear starting and ending point. Okay, and once that is done, you arrange the rest. So you arrange the rest normally, the way you solve. Okay, so again, if you are looking for a formula, right, if you are looking for a formula for circular permutation, it's simple. Solve normally, okay, but replace n by n minus 1. So in all the formulas or all the methods that we have done, solve it normally, just decrease the total by 1. Okay, why does that happen? Because we fix one variable in one position and then solve. Okay, because what happens? We try to fix one variable in one position and then we solve the question. Okay. Right. So if you look here, okay, if you look here, say the condition was all the boys together. Now in a row, okay, in a row, we know if all boys are together, we combine them, count them as one. Answer becomes 7p7 into 3p3. Okay, 7p7 into 3p3. The same thing in a circle will now become 6p6 into 3p3. Okay, why is that? Because what will I do? Say I will fix one girl. Okay, say, right, what will I do? Say this is my circle. I will fix girl number 1. That girl number 1 will sit here. My counting will start from her. So now what do I have? I have 5 more girls left. Okay, what do I have? I have 5 more girls left and the 3 boys. Okay, and the 3 boys. The 3 boys I'll combine into one. I have 6 things now. 5 girls and 1 x. That becomes 6p6. The 3 boys will interchange themselves in 3p3 ways, right? So 6p6 into 3p3, right? So remember, the concept of circular permutation is you fix one person or one variable in one position. Okay, why do we do that? So that we know a fixed starting and ending point of the circle, and then you solve the question normally. Okay, if you have any redundancy here, no problem, just divide by redundant factorial. Okay, things coming together, not coming together, none of them coming together, whatever the question is, whatever the constraints are, solve it normally, but fix one in one first. Okay, if you're looking for a formula, then just reduce the total by 1. Alright, so if you've read this question, what do we know? There are 8 delegates which are to be seated around a circular table. Okay, so 8 positions, 8 circle. The delegate from Germany does not want to sit next to delegate from France. Okay, how many seating arrangements will satisfy the condition? Okay, alright, so let's break it again into 2 parts if you want. Say the question is for rows, if they were sitting in a row, versus question for sitting in a circle. Okay, now had this been sitting in a row, what do? I can simply do total minus the cases when they sit together, right? Total is 8 factorial minus cases when they sit together, that is 7 factorial times 2 factorial, right? Recall this. I'll consider Germany and France as 1, remaining 6 plus this 1, 7, to 7 factorial times 2 factorial. This would have happened if they were sitting in a row. What did I tell you? What happens in a circle? The total reduces by 1. So total now becomes 7 factorial. Okay, if you look at the corresponding total, the total becomes 7 factorial, because the total cases, there are 8 people, 1 you will fix, 7 remain, so 7 factorial. Out of those 7, these two like sit together, so that will be 6 factorial times 2 factorial, right? That will be 6 factorial times 2 factorial. Okay, this is when these two sit together, right? That's it, right? And now you solve. That is 5040 minus 1440. Okay, as I told you in the beginning, factorials up to 10 is something that you should learn, right? So that's 3600. Okay, now let's try and understand this also. Okay, let's try and understand this also. So see, I have 8 spaces. Okay, I have 8 spaces. One of these delegates, apart from the Germany and France one, okay, apart from the Germany and France one, okay, what do? I fix one of those delegates. Say person X or delegate X will always sit here. So now what is happening? Now I have only 7 people left. That is why the total is 7 factorial, right? Now if Germany and France sit next to each other, then what will I do? I'll combine the 2 into 1. So I will have X is gone. I have 5 more delegates and I have France and Germany. If I combine them into 1, that's 5 delegates plus 1, 6. So 6 factorial. France and Germany can interarrange themselves in 2 factorial ways, right? That's 7 factorial minus 6 factorial times 2 factorial, okay, which is 3600. Alright, now let's do some mixed questions. Okay, so if you have read this, we have 5 digit even numbers we need to make. The digits are 6, okay, and no digit is repeated. So again, as I said, because we are doing permutation, don't think permutation, understand why permutation. The question itself mentions repetition not allowed, so it is permutation or combination. Does the order matter? Yes, the order matters, because if I write 4 5 7 9 2 8 or I write 5 4 7 9 2 8, these are two separate numbers, right? So the order also matters. Hence we know there is permutation. Now question comes, what do I want? I want 5-digit number. Okay. What is the constraint? The number has to be an even number. Okay. So the last 2 digits, even 4, 2 and 8. 4, 2 or 8. The last digit has to be made of 4, 2 and 8. As I told you, whenever there is a constraint, get rid of the constraint first. I have 3 options. I want only one in my last digit. So that's 3p1. From these 3, pick any one. Right? Now that that one is over, how many digits are left? 1, 2, 3, 4, 5. 5 digits are left because the total there are 6. 1 is gone. 5 are left. How many do I want? I have 4 options. From 5, I will pick 4. Right? From those 5, I will pick 4. There is no repetition, no redundancy. So no division, nothing. That's it. So that's 5p4, which is 5 factorial by 1 factorial, times 3p1, which is 3 factorial by 2 factorial. That's 120 times 3, 360. Alright, moving on to the next one. We have a company which has a management team of 12 people. Out of those 3, we have to choose CEO, CFO and COO. Okay. Again, the question says nobody can hold more than one position. Okay. How many ways can the roles be assigned? Again, don't just directly jump to permutation. Think why permutation is applicable. Right? Clearly, the question says repetition not allowed. So it's either permutation or combination. What is the difference between the two? The order matters. Now think, say you are the CEO, right? So again, there are 12 delegates. You and I are one of those, okay, or 2 of those, sorry, right? You are selected as the CEO. I am selected as the CFO. So that is one scenario. If I interchange the 2 positions, okay, say A is CEO, you are the CEO, B is CFO, okay. If I interchange the 2, now you will become CFO, I become CEO. Is the case the same? No, our roles and responsibilities perhaps will change. It's a different scenario, right? So this is how you make sure that yes, order matters, because I interchanged 2 values, I got a new case. This tells me order matters. And now that I know order matters, I know I have to use permutation. It's very simple. How many options do I have? I have 12 people, right? How many do I want? I want to take 3 people and assign them 3 positions. So I want only 3 out of those 12. So that is simply 12p3, which is 12 factorial by 9 factorial. Again, don't be scared of the calculation, right? That's 12 times 11 times 10 times 9 factorial over 9 factorial. Cancels out. That's 132 10, 1320. Right? Again, guys, remember calculation is not a problem here. Okay? Question will be solved 50% mentally. Understanding what to apply, when to apply is super important. If you have that clarity, you'll actually enjoy this topic. Alright, moving on to the next one. Security gate requires a 5-digit passcode. Each digit is chosen from 0 to 8 without repetition. Again, this is important. Okay. First and last digits must be even. Okay, fine. How many passcodes can be created? Okay, fine. Without repetition tells me repetition not allowed. So permutation combination. Otherwise, had this not been mentioned, okay, had this without repetition not been mentioned, okay, passcode repetition would have been allowed, because I can, in my passcode I can have 55555, right? So because the word repetition, without repetition is mentioned, we know instead of counting we'll switch to permutation combination. Since it's a passcode, order matters because 1, 2, 3, 4, 5, if that is your passcode, 2, 1, 3, 4, 5 will not work, right? So the order clearly matters. Now, I need a 5-digit passcode. What are the constraints? The first and last digit must be even. So the first and last digit must be 0, 2, 4, 6 or 8. Alright, no problem. We solve the constraint first. I have 5 options. Pick any two, one for here, one for here. So that is 5p2. Okay, 5p2 covers these two positions. Alright, two numbers have been utilized out of total 9. Remember, 0 to 8, total numbers are 9. 2 are gone. Now, arrange the rest. 3 positions are there. I have 7 numbers. Pick any 3. Right? So that is 5p2 times 7p3. That's 5 factorial by 3 factorial times 7 factorial by 4 factorial. Okay. 5 factorial by 3 factorial is 5 times 4 times. Okay, let's just simplify it. 7 times 6 times 5 times 4. 4 factorial cancels out. 3 factorial cancels out. This is 20. Right, this is 20 times 210. Okay. That's 4200. Okay, that's 20 times 210. Okay, this is 20. This is 210. Okay, so that's 4200. Alright, moving on to the next one. We need even numbers less than 10,000 using the digits 2, 4, 5, 7, 9. Again, no digit is repeated. Repetition not allowed. Order clearly matters. Now, less than 10,000, right? So, I can have a single digit number less than 10,000, a 2-digit number, 3-digit number, or a 4-digit number, right? I can have this or this or this or this. You know, we have done in the previous video, or means the answers will be added. Okay. Now, what is the constraint? We want even numbers. So the last digit has to be made up of 2 or 4 every time. Okay. In all the cases, the last digit has to be made up of 2 or 4. Since I want single digit and it has to be 2 or 4, that's 2p1. Right? From these two, I will pick one and that will be my single digit even number. For 2 digit, again this will be 2p1 because out of 2 or 4, any one can come, and the remaining 4, any one can come here. Okay, so that is 4p1 into 2p1. Okay, to make a 3-digit number, again the units digit has to be 2 or 4, one of the two. Remaining 2 digits from remaining 4, any 2 digits I can pick. So that's 4p2 into 2p1. If I want to make a 4-digit number, again 2 and 4 in the end, from remaining 4, any 3. So that's 4p3 again into 2p1. And remember, I'll add because I want this or this or this or this. Right? I take 2p1 common. I get 1 plus 4p1 plus 4p2 plus 4p3. 2p1 is 2 factorial by 1 factorial. 1 plus 4 factorial by 3 factorial, 4 factorial by 2 factorial, 4 factorial by 1 factorial. That's 2 times 1 plus 4 plus 12 plus 24. 36, 40, 41, 41 into 2, 82. Okay. Alright, moving to the next one. So we have a railway station which has 12 stations along its route. Ticket is to be issued for journey between two stations. How many types of tickets can be printed? Right? Again, think, if you want to print a ticket, can you repeat the same station? Can you go from Bangalore to Bangalore? No, right? From 12 stations, repetition not allowed. Now think about the order. So in my tickets, right, if I go from A to B and I interchange the order, okay, so I go, first ticket is from A to B, change the order, B to A. Are they the same tickets? Clearly not. These are two different tickets, right? So we know order matters. Now that we know that, okay, question becomes easy. In order to generate a ticket, what do I need? I need two stations, arrival, departure. Okay, how many options do I have? 12. So answer simply becomes 12p2. Again, remember, calculation is not important. Understanding why we are using permutation, that is more important. Okay, 12p2 is 12 factorial by 10 factorial, which is 132. Okay, we have letters of the word explore. Okay, that's a 7 letter word. Now we want no two vowels are together. Okay, so we want no two vowels to come together. That means all the vowels have to come separately, right? They have to come separately. Even two vowels, E and E can't come together, E and O can't come together, they have to be separate. Okay, no problem. What do we do? Let's write the vowels. So we have E, E, O, X, P, L, R. So these are the four consonants, these are the three vowels, right? If none of the vowels need to be together, what will I do? I'll arrange the consonants first. Four consonants will be arranged in four positions in 4p4 ways, right? Next to these, I have five imaginary positions where I can put any of these three. So that is 5p3. Now remember, E and E are same, so there is redundancy. We have solved everything normally by assuming everything different. In the end, I divide by the redundancy. Right. If you solve that, 4p4 is 24, which is 4 factorial. 5p3 is 60. 2p2 is 2, which is 2 factorial. So that's 720. Okay. Remember, whenever redundancy happens, solve the question normally, divide by redundant factorial. Here we have 6 friends sitting in a circular table. Okay. We also have a constraint. Alex must sit directly opposite Ben and Chris must sit next to Alex. Okay. How many different ways can they be seated? Okay. Alright, fine. Let me make my circle. These are the 6 positions for the 6 friends. This is circular permutation. What do? We try to fix one variable in one position, right? And we start our counting from there. Reading based on the question, I think it will be easy if we fix the position for Ben or Alex. You can pick anyone, doesn't matter. Okay. Let's do one thing. Let's do two cases. Okay. Let's do one thing. Let's do right. Let's do two cases. Right. Pardon me for the mistake. Right. Case number 1. Okay. We will fix Ben. Okay. So this is my circle. Say Ben is here. Okay, Ben is fixed, Ben is here. Alright, now what happens? Alex has to sit directly opposite of Ben. Ben is already fixed, so that's 1p1. This is for Ben. Okay, now Alex, where will Alex sit? Here. For Alex, I have only one position. Alex cannot sit anywhere else. Now for Chris, I have two positions. Chris will sit next to Alex. So I have two positions and one Chris. So that is 2p1. The remaining three can sit in any of the three places. Right? The remaining three friends can sit in any of the remaining three places. So if you solve that, that is 1 into 1 into 2 into 6. 3p3, remember, is 3 factorial. So that's 12 cases. Okay. Now, okay, let's fix Alex. Okay, same, but let's fix Alex. Okay. So again, this is my circle. 1, 2, 3, 4, 5, 6. Say Alex is here. So for Alex, it is 1p1. Now, opposite to Alex is Ben. Right? So Ben will come here. For Ben, I have only one position because he has to sit or she has to sit opposite to Alex. Chris, again I have two options. Can sit anywhere. Remaining three friends, remaining three positions. Solve that. That is again 1 into 1 into 2 into 6. 12 options. So again, it doesn't matter whom you fix. The logic is, in a circular permutation, fix somebody and then proceed. Now here what do we want? We have 5 physics books, 4 chemistry books, 3 biology books. So that's 5 plus 4 plus 3, 12 books in total. Right? We have 12 books in total. Right? Now what is the constraint? Books of the same subject must be kept together. Okay? Books of the same subject must be kept together. Okay? No problem. So we have 5 physics, 4 chemistry, 3 biology. If I want to keep the books of physics together, combine them, count them as 1, x. 4 chemistry, count them, combine them, count them as 1, say y. 3 biology, combine them, count them as 1, z. So I have only 3 units, x, y and z. How many ways can I arrange these? That's 3p3. Right? Now within this x, the 5 physics books will arrange themselves in 5p5 ways. Within the y, right, within this y, chemistry books will be arranged in 4p4 ways, and within this c, biology books will be arranged in 3p3 ways. Right? So that's 3 factorial, 5 factorial times 4. Right? Again, if you are applying the formula, right, if you are applying the formula, that is 12 minus 5 plus 1 minus 4 plus 1 minus 3 plus 1 factorial times 5 factorial, 4 factorial, 3 factorial. Right? If you solve this, that's again 3 factorial, 5 factorial, 4 factorial and 3 factorial. Okay? You'll get the same answer. Next we have letters of the word balloon. We have to make 7 letter sequences. So we have to make all 7, utilize all 7 letters. The two L's cannot be adjacent to each other. Okay? The two L's cannot be adjacent to each other. Okay? Alright. Again, let's look at 2 scenarios. Okay? We'll do one thing. Okay? Because now guys, remember this, super important. Because we have only 2, right? Because we have only 2, you do total minus 2 together, okay, or you do none of 2 together, right? They mean the same. Okay, see, had there been 3 L's, then I do total minus all 3 L's together, then I could have had 2 L's together. Okay, but here because I have only 2 L's, right, I do total minus 2 L's coming together, or I do none of the 2 L's coming together. It means the same, right? So what I'm trying to say is, you apply either of the methods, you'll get the same answer. Okay, let's look into it. Okay, let's see how that happens or how that works. Right? So we have balloon, which is a 7-letter word. Okay, when I'm saying they are not together, initially it's a constraint question. Sorry, it's a redundancy question because you have 2 L's and 2 O's. So solve the question normally by assuming everything to be different. Right? Total cases will be, I have B, A, L, L, O, O, N. I have 7 letters. Total cases will be 7 factorial minus the cases when the 2 L's are together. If the 2 L's are together, I'll combine them into 1 and solve. That is 6 factorial times 2 factorial. Right? Remember why into 2 factorial? Because whenever I'm solving a redundancy question, by default, I assume initially that everything is different. So don't think that, oh, the 2 L's are together, so why are we multiplying? No. Initially, we consider everything different. So 6 factorial times 2 factorial. And now, in order to remove the redundancy, now we will say, okay, because of 2 L's, 2 factorial, because of 2 O's, 2 factorial. Okay, if you solve this, this is 5040 minus 1440 by 4. That's 3600 by 4, which is 900. Okay, now as I told you that because we are talking about 2 things, right, you can do none of the 2 together also, and that should work. So I have B, A, L, L, O, O, N. I'll say the 2 L's should not come together. So I'll make the other B, A, O, O, N sit. So these are 5 letters. They will sit in 5 positions. That's 5P5. Now next to the 5 letters, I have 6 imaginary positions, and I want to put 2 L's in those 2 positions. So 6P2. Again, because of redundancy, divide by 2 factorial for 2 L's, 2 factorial for 2 O's. Right, if I solve this, 5 factorial, right, this will become 5P5 is 5 factorial, 6P2 is 30. Okay, 6 factorial by 4 factorial. Okay, that's 2 into 2. That's 120 into 30 by 4. Okay, if you again cancel this, that's 30. 30 into 30, again 900. Right? So the point I'm trying to make is, if it is only 2 things, you do total minus 2 together, or you do none of those 2 together, it means the same. But if it is more than 2, then you will have different answers. Okay, because the meaning will change. Okay. Alright guys, moving to the next question. We have again 7 letters. The letter R must always appear after the letter S. So we have a constraint here. Redundancy is happening clearly. We want letter R to happen after letter S. Okay. So let's look at a very logical way. Okay. See, I have P, P, Q, Q, Q. Right? 3 Qs. And R, S, T. Alright. R, S, T. My bad, there are 8 letters. Okay. There are not 5, 7. Sorry, there are 8 letters here. Okay. Now, how many words can I make from these? So that's 8P8 divided by 2P2 and 3P3. These are the total words that I can make. Right? That's 8P8 by 2P2, 3P3. Right? These are the total words that I can make from these 8 letters. Now think, if you are sitting in a row and if you just focus on RNS, okay, if you just focus on RNS, see, the question says R comes after S, does not mean that R has to be immediately after S. Okay, the word could be P, P, Q, Q, S, Q, R, T, right? R has to come after S. Where it comes, that does not matter. Okay, R has to come after S. Where it comes, that does not matter. Sorry, right, let it be. Okay, now but what will happen if there are two letters? What are the choices? See, R can come either left of S or R can come right of S. There are only two options, right? And since it's all symmetric, what will happen? Half of the cases R will come left of S, other half R will come right of S. Okay, so if I just figure out the total cases first, that's 8 factorial by 2 factorial 3 factorial, that's 8 factorial, right, which is 40320. Again, I am telling you, you should know the factorials up till 10, divided by 2 factorial 3 factorial, which is 12, right? If you solve that, okay, if you solve that, that is 3 2 3 3 3360. So total 3360 words can be formed. Okay, total 3360 words can be formed. Don't rush, don't mark the answer. This is just total words. Remember, this 2 is left. Half of these cases R will come before S and half of these cases R will come after S. Okay, that's 1680. Okay, now if you want, right, I hope you understand that, right? If you want, say if there are more than two letters, what do we do, right? Then I won't count cases and all. I'll tell you a very simple way, okay, to think, right? See, remember, what is it? This is something that I am supposed to do, right? I have to ensure, I have to make words, okay, and in those words I have to ensure that R comes after S. Okay, that's my job here, and then I'll see how many possibilities are there. So what I'm going to do is, right, I have P, Q, Q, Q. Okay, now R and S I will replace by the letter X. Okay, I am replacing R and S both by X. Okay, and T. T is T. Why am I replacing both of them by X? Because see, it's my job to make sure R comes after S, right? So I have replaced both of them by X. Now I'll form a word. Okay, now I will form a word. Okay, wherever the first X comes in that word, I will compulsorily put S there, and wherever the second X comes in the word, I will compulsorily put R there. Thereby I am ensuring that S is always coming before R. Okay, for example, I make a word P X P Q X Q Q T. Okay, this is the word I found. So what will I do? Compulsorily, in place of X I will substitute S, in place of X I will substitute R. Thereby I am always ensuring R is coming after S. Now question comes, okay, how many ways then? So I have 1 2 3 4 5 6 7 8, 8 letters, that's 8P8. 2 P's, so 2P2. 3 Q's, so 3P3. 2 X, so 2P2 again, right? So that's again 8 factorial by 2 factorial 3 factorial 2 factorial, that is 1680. Okay, this is another way to think about this. Alright guys, so this brings us to the end of the video. Okay, I hope you were able to understand the concept of permutation. More importantly, the fear of what is permutation, what is combination, I hope that goes away, right? Remember, right, it's all about mental clarity. Okay, 50% of the question is solved mentally. You need to understand when to apply permutation, why to apply it. Okay, if you understand that, 50% of the question is done. Okay, so with that said, remember, combination is still left. We have done counting before this video. Okay, we did permutation in this one and combination in the next one. Okay, so if you like it, then I hope to see you in the next one. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.